Hey everyone, in this video I'll be telling you a bit more about image file formats. So the goal is that you understand what are the different types, what are the differences between the different types, which one you should use, why and when. So because this video is a bit more technical and does not exclusively concern Inkscape, feel free to skip it. However, if you do, here are my basic recommendations. The first one is you should only use PNG and TIFFs for raster images. The second one is you should use SVGs for vector graphics. And the third one is you should use PDF, EPS or WMF files for compound graphics. You should never ever use JPEG if you can avoid it. Alright, so the rest of the video will consist of me explaining why I'm saying this, and I also have a few examples prepared for you. So let's get started. The first major category of images are called raster graphics. They are the images that you're used to seeing. They basically are pixels arranged on a grid. Each grid can be represented as an array of pixel intensity. If you have this 2D array, you basically have an image that can be expressed in black and white. Black being the lowest value, white being the highest value. If you want a color image, you basically stack 3 matrices together, giving you one for red, one for green, and one for blue. This gives you color. Common examples of raster graphics would be JPEG, PNG, TIFFs, and many others. Because raster graphics are made out of pixels, and a finite number of pixels at that, they have an intrinsic resolution. Modern computer screen, or computer monitor, which corresponds to a resolution of 1920 by 1080, that's in pixels. A 720 resolution would be 1080 by 720. A 4K resolution is 4 times 1080p. So it gives you 3840 by 2160. The first number corresponds to the horizontal axis and the second one to the vertical axis. For general knowledge, 1 megapixel corresponds to 1024 by 1024 resolution. Essentially, higher resolution will give you a better image, however, it will dramatically increase the file size for the image. In the same way, a lower resolution will worsen the quality of the image, however, the file size can be quite small. This leads us to a potential space-saving problem and solution. So again, because raster image can be quite large in file size, there is a common practice to compress the image. Compression is a process by which you reduce a file size. It can be any file. For instance, a zip is just a compressed regular file on your computer. In the case of images, you want to reduce their file size without affecting their quality. Keep in mind that a compressed image always has the same resolution as a non-compressed version of the same image. It's not about reducing the resolution, it's about compressing the information. There are 3 types of compression. The first one would be uncompressed. TIFFs can be uncompressed if you want. Lossless compression is the second type. You have TIFFs and PNG in that category. And the third one is lossy compression, such as JPEG. Lossy compression is very bad for us because it reduces the quality of the image, and especially wherever there are sharp transition in pixel colors, such as text. Here's an example. What I did to show you the effect of compression on an image is I created this simple image with Inkscape and exported it as a PNG. Again, PNG has a lossless compression, so we won't see any compression artifact here. So if we zoom, we end up seeing pixels, as we might expect, but the transition is very sharp. It goes from white to orange here, from red to white, and the text, again, very clear. However, if I compress this image as a JPEG with varying levels of quality, I will get some compression artifacts. Here's the case with 100% quality, meaning the lowest compression level. Still looks fine, we still see pixels, and we don't see any compression artifacts. However, as soon as I go to lower level of compressions, with 50% quality for example, and I zoom again, now I can see clear compression artifacts surrounding the text. Mind you, it's still the same original resolution of my PNG, it's just that the compression lowers the quality. It adds some fuzziness around the sharp transitions. If I look at my triangle and the circle, the effect gets much worse if I look at a 1% quality image or the highest value for compression. This is unusable, even though it's still a 1 megapixel image. In addition to all of this, PNG supports more color spaces than JPEG. For instance, a very useful one for us would be the RGBA color space, meaning that you can add alpha values to pixels or transparencies. This is especially useful if you want to add your image in a presentation with a non-white background, meaning that you won't see the ugly white borders surrounding your image. Can be very useful. So in summary, whenever working with raster images, you should either be using PNGs or TIFFs. TIFFs support most of the features of PNG, however, there is a possibility to use uncompressed TIFFs, whereas every PNG has a lossless compression. Moving on to the second category of image formats, vector graphics. Vector graphics are very different than raster images as they do not have any pixels. Instead, the information for the image is recorded as parametric curves or equations. The fact that they are no pixel means that they basically have an infinite resolution. This is the best image type for us. Examples of vector graphics would be SVGs, which is the native type of Inkscape, and AI is another common example for Adobe Illustrator. You should always try to prioritize vector graphics for your use instead of raster images. Here is a quick example. As you can see, I just opened my original sample image in Inkscape. It's the same one that I exported as PNG, however now, if I zoom, you will never see any pixel appearing. The resolution of the SVG is always recomputed to match the resolution of my screen, hence no pixels. The third and last major image category would be compound images. They support both raster and vector data. In addition, they also support other types of data. For instance, other data could be input forms, such as PDFs. Yes, PDF is a type of compound image. Other examples would be EPS for encapsulated PostScript and EMF/WMF, which are Windows metafiles. Windows metafiles can be very useful if you want to work with vector data in Microsoft Office programs. To my knowledge, Microsoft Office does not work very well with SVG images, so if you want to add a infinite resolution image in a PowerPoint presentation, I suggest you save it as a Windows metafile. Then, you should be able to import it within PowerPoint without issues. To show you that PDF is indeed an image file, I imported both my original SVG, my PNG, and 2 JPEG in the same SVG document, which I then exported as a PDF. Here it is. The first thing you can see is that if I zoom, you will see that the top left portion of the image, which is the original SVG, still is a vector graphics, meaning that I can zoom in and not see pixels. However, if I do the same thing with the top right portion of the image, which was the PNG import, I see PNG pixels, but no compression. If I go look at the bottom left, which is the 50% quality JPEG, I see both pixels and compression. And the worst one of them all, the 1% quality JPEG that you should dread, PDF does not make it much better. So that's it for this one. In summary, you should use only PNGs and TIFFs, and again only for raster images. You should use SVG images for vector graphics, and PDFs, EPFs or WMFs images for compound graphics. Avoid at all costs the dreaded JPEG. So I'll see you in the next video where we will finally get our hands dirty with Inkscape for the first time. See you then.